Can everyone see my screen okay?
I can see it.
Great. So hey everyone, I'm Shreyas Kaur and I'm the founder and CEO of Community AI. And I would like to welcome all of you to our 2021 AI Summer Camp on Machine Learning from Louisville, Kentucky. And we have many students from several cities, states, and countries, encompassing many different time zones. And because of that, it may be very early in the morning or very late in the night for some of you. And I really appreciate all of you guys joining us today. As a heads up, we will be recording this meeting for your future reference. So in terms of the outline today, first we will introduce Community AI and the team. Then we will go on to introduce the AI Summer Camp. And after that, we'll start the meat of the lecture, which will focus on introducing machine learning and some common applications of machine learning. Before we actually start the lecture, I would like to introduce our organization. So Community AI is a student-driven organization that aims to empower middle and high school students to create AI-driven projects to help the community. As you all know, AI has boomed in popularity in the last few years and has been used in various applications, including business, agriculture, education, and everything in between. And this has sometimes revolutionized these industries and have overall had a massive impact on the community. In fact, many of the things I use on an everyday basis, from entertainment products like Netflix and educational products like Khan Academy, use AI to operate. And despite AI having a huge impact on the community, not many students actually create projects. And this, at least to me, was very surprising because after all, many students are very bright. And on top of that, these bright students genuinely want to help the community. And this overall puzzled us greatly. However, after experiences, we came to the conclusion that two factors prohibited students from creating these projects. The first was the fact that students simply did not have the knowledge needed to create AI projects. And second, and that was the fact that students who had learned AI through online courses, even many of them, they didn't have the proper guidance to take on large-scale projects. And we discovered that there did not exist an organization currently there to help students with these problems. And to that end, we created Community AI to empower middle and high school students to create AI-driven projects to help the community. And our AICamp in previous years were extremely successful, with many students using their knowledge and skills here to create many projects that have had a great impact on the community. We hope that you can gain valuable skills from this camp and apply it to problems that you care about. So now we'll introduce our lecturers. So first I'll introduce myself. As I said before, my name is Shreyas Kaur, and I'm the founder and CEO of Community AI. I've developed several award-winning projects for the benefit of the community and the environment, and I'm excited to share my knowledge with you guys. Shraman, can you introduce yourself?
Yep. Hi, my name is Shraman Kaur, and I'm the co-founder of Community AI. I'm really excited to be part of this camp and welcome you all to this camp and hope you all learn something.
Thank you, Shraman. Dr. Willard, would you like to introduce yourself?
Sure, thank you, Shreyas. My name's Jeffrey Willard. I have a PhD in applied mathematics, and I am the technical lead or technical mentor for the Community AI organization and the chief mentor and advisor. So I'll be helping out with several of the lectures, as well as helping answer questions on the platform.
Yeah, thank you, Dr. Willard. We would also like to introduce our teaching assistant, so it will help answer some of the questions that you guys may have. Veer, would you like to introduce yourself?
Yeah, for sure. So hi, everyone. My name is Veer. I'm calling in from Ontario, Canada. I'm very passionate about AI and excited to help out with this camp.
Thank you, Veer. Pooja, would you like to introduce yourself?
Yeah, for sure. Hi, guys. My name is Pooja. I'm from Bloomfield Hills, Michigan. I'm a rising senior in high school. I'm also really interested in science and artificial intelligence, and I love to code and learn more about AI and how it can be used to positively impact people. And I'm super excited to be helping you guys out this summer.
Thank you, Pooja. Lastly, I'll talk a little bit about the logistics of the camp itself. So we will have a question and answer session at the end of every lecture. However, if you have a question in the middle of the lecture, feel free to post it in the chat. If you haven't yet joined the Google Classroom, please do so. Our join code is UDU5QEM. And we will post assignments in the Google Classroom after the lecture is over. And the assignments are due in 1 week after the assignment is posted on the Classroom. assignments are audit rated, and the pass score of 80% is needed to actually pass the assignment. And you can take it as many times as you want to actually get the passing score. We will also have certificates for the completion of this course. Specifically, you will earn a certificate if you join at least 5 of the 6 lectures, pass all the assignments, and submit your final project. We will send a certificate via email 2 weeks after the end of the camp. Specifically, that is 2 weeks after the submission of the final projects. We understand that some non-US students may not be able to make it to the lectures due to time zone difficulties. So students will let us know that they can't. Because of that reason, we will actually make a small exception for them, and they will be able to get a certificate if they merely finish all the assignments and turn in the final project on time. Finally, all the lectures will be at the same Zoom meeting. So the same Zoom meeting as this at 7 p.m. Eastern time. And for more details about just the camp and the schedule, please visit our AICamp website at this link. With that being said, I'll pass it over to Dr. Willard, who will be giving today's lecture, and he'll start off by introducing the AICamp. Dr. Willard?
Yep, thank you, Shreyas. Would you like to continue clicking through the slides, or would you like me to share?
It would be better if you would share. Let me just stop sharing and you can start. Is that fine?
Okay, yep. All right, can you see my screen now?
Yep, I can see it.
All right, great. Thank you, Shreyas. So welcome. I'm excited to be working with all of you this summer. So as I mentioned, I have a PhD in applied mathematics, and I've been doing data science and machine learning for about 5 to 7 years now. It's a very interesting field. It's a field that changes often, and I'm excited to be able to share this knowledge with middle and high school students who have a passion for learning about science and technology. So as Shreyas noted, this class is directed for middle and high school students with an interest in learning about machine learning and AI. We expect that all students will have had at least an introductory algebra course, but students are not required to have had prior experience with programming or knowledge of calculus. This will be a little challenging at times. We will do our best to make concepts simple and promote them in a way that doesn't require knowledge of calculus. But obviously, for those of you that do have that background, many of these concepts will make more sense, and you'll be able to understand the theoretical background in more detail. In terms of the course goals, we'd really like for everyone to learn basic ML concepts in common types of machine learning problems. We're going to try to give you some exposure to many of the most common machine learning algorithms and give you exposure to the Python and Octave programming languages. And ultimately, we'd really like to inspire students to begin building projects that benefit their local community. So we're all at a course about machine learning. We should start off by defining it. So what is machine learning? Machine learning is the study of computer algorithms that learn automatically via experience. So there's a very technical definition here, which I'll read, but maybe this isn't the best way to really think about it. A computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at task T as measured by P improves with experience E. All right, that was a mouthful and probably doesn't make a whole lot of sense. Basically, what we're trying to do is design algorithms that learn given data, and sometimes that data has labels, sometimes it might not, and we'll talk about that more in a bit. But essentially, these algorithms are asked to perform some task, and generally, we hope that they perform better at that task as we give it more data to learn from. So basically, machine learning practitioners design algorithms which allow them to train computers to solve specific problems within a defined framework. And hopefully this will make a little bit more sense as we get a little deeper into the slides. There are 3 main types of machine learning problems. These types are supervised learning, unsupervised learning, and reinforcement learning. We'll talk about all 3 of these in this course throughout the next few weeks. However, recently there has been some progress in a field called semi-supervised learning, which kind of falls between supervised and unsupervised learning. This is kind of beyond the scope of this class, but is something that you might want to dig into if you're still interested once we've completed the basics. So let's talk about supervised learning. This is probably one of the most common types of machine learning that many of you are likely already familiar with to some extent. The computer is provided with a set of example inputs and their associated outputs, and the goal is to learn a rule which maps inputs to outputs. So one thing you might be familiar with is a concept called regression. So predict a numerical output based on a set of inputs. Let's take a look at an example. Let's predict the price of a house given its location, the year it was built, the size of the home, maybe that's in square feet or square meters, and the size of the lot. There might be other attributes, such as the number of bedrooms, the number of bathrooms, that impact the value of the home. But we want to design an algorithm based on historical sales prices of homes to predict what a new home might sell for when it goes on the market. Another example of supervised learning would be classification. And this is predicting an output label based on a set of inputs. So with regression, we were trying to predict a continuous variable, right? A price can really be any real number. Maybe we round it to the nearest cent. However, with classification, we are trying to predict a discrete set of classes. So for example, given a picture of an animal, determine its species. There are only a finite number of species, and we can train a computer with fairly high accuracy to determine species based only on a picture. As a second example, we might, if we were a bank, want to predict whether a client will default on a loan based on their financial history. Again, this is predicting one of 2 classes in this case, whether they default or they don't default. So these are a couple of very basic examples of regression and classification, which we'll talk about in more detail later on. The next main topic in machine learning is unsupervised learning. And here, an algorithm is provided an unlabeled set of data points and asked to find some underlying structure or patterns in the data. Remember, with supervised learning, we were trying to predict a specific quantity, and we had data that was already labeled that we could use to train the model on. In this case, we might not have any labels. One example of this would be clustering. So determine a grouping of objects such that the objects within a group are more similar than those objects in other groups. One example of this might be anomaly detection. So find the data points which don't align with the general trend of historical data. So maybe make that more concrete. Maybe you're looking at water usage at a site, maybe at a farm, and you see that it uses about 1,000 gallons a day every day, but one day it uses 10,000 gallons. That's an example of an anomaly that you might be able to identify with something like clustering by grouping together points that look the same and finding ones that might exist as part of a different group. A second example would be in online advertising, where we might analyze historical buying patterns or internet navigation patterns to find customers with similar interests. So maybe you see that I've purchased a lot of equipment for my bicycle, and so has another individual, they might recommend that I buy some products that the other individual has already bought. This is a way that they can increase their revenue and use buying patterns to impact new behavior. There are also some other examples called component analysis, latent space analysis. These are generally dimension reduction techniques, which we'll talk about a little bit later in the course, but are an interesting field of study. The third type is actually one of my favorites, something that I get very excited by and actually am using on a day-to-day basis at my job. It's called reinforcement learning. And in reinforcement learning, we train an agent to interact with an environment in which it seeks to achieve some goal. As the agent gains more experience, it learns to maximize observed rewards. So for example, we might train a self-driving vehicle, which learns via simulated experience to navigate safely from a starting point to a destination. And we might give it rewards for reaching that destination, and we'd probably give it some penalties if it were to, say, leave the roadway, run into another vehicle or a pedestrian, or we might penalize it if it takes too much time to get there. By giving the vehicle a significant amount of background, it can actually learn on its own the best way to accomplish tasks. Another example, which you might be familiar with, is computer agents or bots, which learn to play video games based on self-play to achieve superhuman performance. So there are examples in video games and in board games. This was originally applied to the game of chess. And right now, I'm going to try to share a video. It's just about 1.5 minutes of how these reinforcement learning algorithms were applied to the game of Go. So Shreyas, you're going to have to tell me if this works in a minute.
Yep, we'll do.
Can you see my screen?
Yep, I can see your screen.
Is the sound coming through?
I can't hear the audio.
All right, I will go back and try this again. All right, I need to share sound. All right, let's try this again.
Go is the world's oldest continuously played board game. It is one of the simplest and also most abstract.
Beating a professional player at Go is a long-standing challenge of artificial intelligence.
Everything we've ever tried in AI just falls over when you try the game of Go.
The number of possible configurations of the board is more than the number of atoms in the universe.
AlphaGo found a way to learn how to play Go.
So far, AlphaGo has beaten every challenge we've given it.
But we won't know its true strength until we play somebody who is at the top of the world, like Lee Sedol.
A match like no other is about to get underway in South Korea.
They said all is to Go what Roger Federer is to tennis.
Just the very thought of a machine playing a human is inherently intriguing.
The place is a madhouse.
Welcome to the DeepMind Challenge.
The whole world is watching.
Can Lee Sedol find AlphaGo's weakness? Whoa. Is there, in fact, a weakness?
The game kind of turned on its axis.
Well, look at his face.
That is not a confident face.
It's developing into a very, very dangerous fight.
Ooh, hold the phone. Lee has left the room.
In the end, it is about pride.
I think there's something went wrong.
Yeah, it's made a mistake. It's got to pronounce a miracle.
These ideas that are driving AlphaGo are going to drive our future.
This is it, folks.
So let me go back to my slides now. All right, Shreyas, can you hear me again and see the slides?
Yep.
All right, thank you. Hopefully everybody was able to see that. If If it didn't work, we can include that link in the chat, and you can watch it on your own time. The full video, I believe, is available to watch on both Netflix and I think YouTube, if you're interested. It's a very interesting story about basically the first time which machine learning AI experts were able to successfully defeat a Go grandmaster. Very, very interesting story. So let's talk about maybe one of the goals of why some of you are here, and that's because you're trying to become a machine learning practitioner. The way to do this is fairly straightforward. Now, I'm not going to say it's easy, but let's look at the following few steps. You need to become familiar with at least one programming language that's commonly used for machine learning. Right now, most of the work in machine learning is done in Python, R, or MATLAB. However, there are also other languages which are common, including Java, C++, Julia, and others. If you already know one of these languages, great. But if not, they're not too hard to learn. They just require a good grasp of logic, and there are plenty of free resources across the internet that can help teach you one of these programming languages. Second, we need to learn the terminology and the concepts, and this course will be a great way to get started with that. And then you also need to study a variety of academic fields to build a strong understanding of how these algorithms are implemented, how they work, and the assumptions that are required to use them. So in mathematics, eventually you'll want to learn calculus, linear algebra, and a course called numerical analysis or algorithms, which specifically studies how algorithms are created and how to measure how complex they are. And then in computer science, we need to understand programming, we need to understand databases, and we also need to understand a concept called parallel computation. If you're not familiar with that, parallel computation is basically the computer science activity of letting a computer work on multiple things simultaneously. So instead of going through a checklist one by one, it might work on 4, 10, 100, or if you have a supercomputer, maybe millions of computations all at the same time. And then you need to read articles. So this field is rapidly changing. Books are a great way to get started with basic concepts, but the applications change daily. So there's a website called Towards Data Science or medium.com. Both of these websites have articles which are posted daily that various people throughout the community are posting articles to. They're very interesting. So that's a good place to go to kind of understand some of the recent changes and advancements in the field. And finally, you just need to practice. While this is a very technical field, I would consider it a science. However, there's also some things that you just get good at by doing it, which makes it kind of like an art in some cases. There's a website called Kaggle. You can go to kaggle.com, where there are data science machine learning competitions which are hosted. Right now, there's, I think, 10 or more active competitions. A lot of them are very interesting. So let's look at a few common applications of machine learning and AI. This list is by no means exhaustive. This is just a few very simple examples. So one of the fields that I'm interested in, because it's the field which I work every day, is the field of energy. And we can use AI and ML in optimizing the production of energy, the management of energy resources, and many other ways. For example, we could even use it to predict how much energy will be produced by a solar array or a wind turbine, tomorrow, the next day, or a few days down the road. And that can help us schedule additional power plants that might make up for the gaps in those renewable resources. Machine learning and AI have become very common in medicine. in diagnostics, medical imaging and radiology, also in epidemiology. So as a very recent example to this, last fall, Community AI had a guest speaker from Los Alamos National Laboratory who discussed his work using machine learning models, data science models, and math models in trying to predict how the COVID-19 virus would spread. They actually did a very good job, had one of the leading models. So this is a very relevant field of study for medicine. We'll also look at a really cool example in medical imaging in a few slides. In finance, there's a lot of applications as well. So one we just talked about is loan acceptance. Do we think an individual is capable of paying back their loan? We can predict yes or no using a history of their finances. Another thing that's very common today is automated stock trading. So machines are trying to predict whether stocks will go up or down in value, and they're combining many data sources, including other stocks, maybe even recent news, could be things like tweets, to try to get any advantage they can to decide, which stock is going to be the most valuable 2 days from now, 1 day from now, maybe even only 5 minutes from now. Machine learning is playing a big role in that. In entertainment, it's also very common. So many of your streaming audio and video services, for example, Netflix or Pandora, are providing recommendations by looking at how you feel about movies or songs and finding individuals who are very similar to you and sharing some of their favorites as well. It's a concept called recommendation engines. Also in gaming, we looked at a good example there for a board game, but also in video game bots. If any of you play Dota, there's a interesting video about training AI opponents for Dota that is actually world class. And in the government, there are many applications in military and defense, in law enforcement, and in public safety. So really, what I want you to take away from this slide is that pretty much no matter what your interest is, there's an application for data science and machine learning. This spring even, we had an individual who works for a professional baseball team in the United States come and give a talk. And he talked about how they're using machine learning and cameras throughout the stadium to analyze the play of every player in the league and try to understand which players are best and which ones are most valuable to the team. So really, the opportunities are pretty much endless. So as I mentioned in the previous slide, one example might be medical diagnostics. So this was based on a Kaggle competition that was launched last year. They were looking at trying to predict lung function decline in patients with pulmonary fibrosis based on some basic information and CT scans of each patient's lungs. So here's an example of a CT scan on the right. So there's both image data, the CT scans or the x-rays, and tabular data, maybe the patient's name, their age, their gender, whether or not they're a smoker, and other historical medical history. An example we kind of noted earlier, but would be fraud detection. So across the world, credit cards are used billions of times a day. It might even be trillions of times a day. Who knows? It's a lot. They're used both across the world and across the internet. And many credit card companies provide guarantees that their clients will not be responsible for fraudulent purchases made with their cards. So credit card companies need to make very quick decisions, think milliseconds, maybe 10 milliseconds, regarding whether or not to approve a transaction. So this is an example of classification. Each transaction needs to be labeled as fraud or not fraud. If it's fraudulent, the credit card company needs to decline the transaction so that that card can't be used. Most of this data is tabular, but it comes in many different forms. So we've got numerical data. This is the kind you're probably very familiar with. So maybe the purchase amount, what time of day the purchase is being executed, the frequency of purchases on that card, etc. There's also categorical data. So this is data where things fall into distinct categories or groups. So was it an in-person transaction or an online transaction, for example? And maybe even some geographical data. What was the location of the purchase? What was the IP address of the purchaser in the case of an internet purchase? Something that you probably have experience with on a daily basis as well is spam detection and spam filtering. So when you go into your email, you'd like for only the most important emails to be in your inbox, and those bogus credit card offers or other junk to be put in your spam folder. So labeling email as spam is a very important feature offered by many email providers and corporate IT divisions. Spam email wastes time, and it can also lead to computer viruses, financial loss, and negative publicity. So this falls under a subfield of machine learning called natural language processing, or NLP, which concerns itself with extracting information from text. Most of the work that's been done in this field was initially in English, but now there are NLP packages that exist throughout the world and for many different languages. Some aspects of spam filtering might be quite simple, such as looking for a word or a phrase that occurs commonly in only spam email. And others are much more complicated, such as extracting meaning from text. Another example, one can often tell if an email is spam or phishing, that's phishing, which is an attempt to gain login credentials or other information. Often these emails have misspellings or poor grammar. So to be able to identify that, NLP needs to be quite complex and be able to identify when when poor grammar is used or when words aren't spelled correctly. Here's an interesting example in the field of reinforcement learning, and that's traffic light control. So many of you probably live in big cities or have at least visited a big city in which traffic can be terrible. Might be very time consuming to even move a very short distance. One way that we can attempt to alleviate this problem is by better controlling traffic lights. So on the right, we see an example of a network in which there's just some parallel and perpendicular roads. In this example, north, south, east, and west. And the goal in this example is to time the lights so that traffic moves most efficiently. Traditionally, the methods for optimally controlling these traffic lights is very complex and might not be adequate as we observe larger and larger traffic networks. Reinforcement learning, on the other hand, has shown a lot of promise where agents can learn on their own by trying a variety of strategies, what we might call policies, based on a system of rewards and penalties. So in this case, many agents might work together that can share information across the network to try to move traffic as efficiently as possible. And a final example would be recommender systems. Again, this is something we talked about a few minutes ago. But say, for example, you're a company like Netflix with a large library of movies and television shows. As users watch and rate shows, Netflix recommender systems can learn patterns among similar users and use those patterns to promote specific content and improve its recommendations. You might see things like If you liked X, you might also like Y. This is probably an example of a recommender system at play. And as a second example, Amazon has millions of different products which they distribute across the globe daily. And each time you make a purchase or even view an item, Amazon is learning from that experience. It can provide recommendations for additional projects which might go well with the product you just purchased, or suggest a different product when you ultimately decide not to make a purchase. It also might just remind you about something that you thought about purchasing the last time you logged in. All of these examples help Amazon make more money and deliver more products. So let's kind of start wrapping up the content section of this lecture with some closing remarks. Machine learning is a very exciting field, which, as I mentioned, is growing on a daily basis, both in terms of the number of practitioners, the number of businesses employing machine learning, and the research which expands and improves on machine learning algorithms daily. This middle point here is very important. The number of applications of ML is innumerable. We want to teach you machine learning so that you can use your individual creativity, your individual skills to apply machine learning to new fields and make the world a better place. And we would love to work with you to build ML projects that benefit both local or global communities and the environment. Over the next few weeks, we'll be providing a basic understanding of a variety of these ML algorithms and concepts, and you can reach out to us via our website at any time if you've got interesting ideas, if you've got questions. You'll also see some examples of ML projects the team has already built, as well as some videos which explain additional machine learning concepts, although many of these we'll cover in future lectures. So with that, that kind of wraps up the content portion of the lecture. I see we've got a lot of questions in the chat, so let's maybe get to some of those. Shreyas or any of the TAs, I don't know if you want to kind of highlight individual questions that should be answered.
Sure, yeah. I'm actually currently answering some of the questions that people have sent me through private messages.
Okay.
Yeah, sure.
So one question, someone mentioned authenticated articles. So websites like Towards Data Science do allow basically anyone to post. So it is not guaranteed that every article you read will be 100% accurate. So that is one of the downsides of it. But on the other hand, it does allow you to kind of gather more information. So it's a balancing act. You know, if an article's not well written, if they don't include much math, maybe it's not the best article. Good articles will have citations, which will point you towards the original sources. Maybe those are articles, maybe those are blogs, maybe they're just web pages at an academic institution. All of those are great places to find articles. Other companies like DeepMind, they will post white papers on their website regularly. So that's an interesting place to go. And they're always one of the leaders in this field. So they're often doing stuff, you know, before it's out in the mainstream. So that's another great place to go. Are there other questions? We kept this lecture intentionally a little bit short because we assume that, you know, since many of us are very new to this field, there will be lots of questions from the audience.
Yeah, feel free to unmute and ask any questions or ask in the chat if you feel more comfortable there. Yeah, Dr. Willard. So he's asking how if So as a beginner, would Kaggle competitions be too difficult to start off?
Yeah, that's a great question. So Kaggle has a variety of competitions available. Some are specifically designed for beginners, and some of them actually have examples of how to solve problems. Kaggle also has a learning section, which provides videos, some lectures, some notes on how to do things. So yeah, it's a great resource for both the very beginner and the expert. At the expert level, people are coming up with new ideas to solve problems in better ways. And there's competitions in a variety of fields, both in regression, classification. There's even one right now in reinforcement learning. For any of you who have played the game Snake, it's a old game, maybe 30 or 40 years old, where a snake travels around a screen and you control it to try to eat food and make sure it doesn't run into any obstacles. Kaggle has a competition right now about trying to train a bot to play that game. So it's very, very interesting. I see a couple of other questions here. In terms of learning a programming language, there are lots of free options available. There are websites such as edX, which is a free online learning platform, which has a variety of programming languages that you can learn. I believe it's edx.org. Maybe Shreyas or Shraman can check that for me real quick and post the link. MIT will post their classes. It's a great place to learn introductory Python. It's a great place to learn even calculus or linear algebra. And there's a lot of other websites that can be used as well. Yeah, and as Shraman noted, there are a lot of free resources on YouTube, both for programming, for math, for machine learning. In all of these related fields, there's a lot of free material. And we can help you find it. If there are specific things that you're looking for and running into issues, feel free to post it in the Google Classroom, and either myself or Shreyas or Shraman or one of the TAs will definitely help you. Somebody asked, there's a couple of questions around the same thing about programming languages. Which one is best? There's no right answer to that, and it kind of depends on what you want to do. I happen to think Python is the most useful for what I do and for what my team works on. So I would recommend that, but many people like R, many people like MATLAB or the open source version of MATLAB called Octave. Any of these are good choices, and really any of them help you kind of learn the concepts and get familiar with the main ideas. So any of those would be great choices. And if you already know something like Java, feel free to just keep using it and learn about the machine learning packages that are available to you there. Someone here asked about TensorFlow. TensorFlow is an advanced concept. We'll maybe talk about it a little bit. I think in lecture 4, lecture 4 is around neural networks. Neural networks are a large class of algorithms for solving a variety of problems. They're useful in supervised, unsupervised, and reinforcement learning for regression, classification, clustering, all kinds of different things. You've probably heard a lot about neural networks. They make their way into the popular media, and TensorFlow is a package that helps us define and train neural networks. We probably won't talk about TensorFlow specifically in this course, but it's something that we should hopefully get you more ready to look at on your own after week 4. Shreyas, somebody asked about a roadmap for the course. Do you have, can you tell everybody what the 6 lectures are about?
Sure. So you can actually find a lot more information about this on our website. So let me actually link the AICamp 21 website to it. So essentially, so today's was Introduction to Machine Learning. On June 10th, we will have a lecture on linear or polynomial regression. On June 15th, we will have Introduction to Classification. We will talk about logistic regression. On June 17th, we will have an introduction to neural nets. On June 22nd, we'll be talking about the very important concept of data analysis and data preprocessing. June 24th, we will have our final lecture on reinforcement learning. And July the 1st is going to be our final project deadline. And that's going to be the end of our camp. So let me actually share this on this Zoom chat. 1 second.
Yeah, I already shared it.
Oh, thank you, Sharman.
So there's questions about books in AI. There are a lot of great books. One of my favorites is sitting on my desk. It's called Python Machine Learning. This is available at Amazon. This is the second edition. I actually have the third edition also in my desk. So clearly I liked it enough to have bought a second copy. It does a great job starting from scratch, and it will also help you learn Python along the way if you're not completely familiar with Python concepts. Once you get into more advanced material, there are plenty of good books. Again, if there's something specific you want to learn about, post something in the Google Classroom and we're more than happy to help. I've also got my favorite reinforcement learning textbook that's never more than a few feet away from me at my desk. These books are great references, but at the same time, like I mentioned, this field changes fast. So there's a lot of good online resources to use as well. And a lot of the online resources are free instead of spending, $50 or $100 on a book, depending on what it might be. Shraman or Shreyas, do you want to talk about the final projects? There's a couple questions about that.
Yeah, sure. So I saw that there was a question about if it's going to be group or individual. So we will permit group projects. So we haven't quite decided on the maximal amount of people per group, but I would expect it to be around like 2 or 3 people. So again, and we're not quite sure if we're only thinking about ideas or maybe some inroad on implementation, or or actually have them create a project itself for our final project. And we'll let you know about that very soon in the coming weeks.
And I'll keep reminding you, the course homepage in Google Classroom is a great place to reach out to us. We'll check it very regularly. You can ask questions about the homework, the project, learning in general, or if you want to get in touch with us about maybe a project that you have in mind, we're also happy to help there. Someone asked if Java was more viable than other programming languages. Maybe, maybe not. I mean, it's a good choice. There's not necessarily a wrong choice. Java is one of the more commonly used languages for machine learning, but I wouldn't say it's the top. Probably it's maybe 4th or 5th on the list behind Python, R, MATLAB, and maybe something like Julia. Maybe Java gets used more often. I don't really know. As for Python, yes, Python 3 is most commonly used now. That said, there are a lot of Python 2 implementations of algorithms that are still out there. So if you only have Python 2 available to you, you can still get a lot of stuff done. And at least in this class, we talk a bit about individual libraries which you can use that have some of these algorithms available to you. But it's also good to just code these algorithms from scratch, especially the simple ones, so that you can kind of learn how they work and gives you a better feel for how they should be used. And if you see something weird, maybe it's not giving you the solution you want, having your own implementation kind of helps you work through the details and figure out where things aren't going right. Somebody asked about SQL. That's SQL, or Structured Query Language. It is something that's important to learn, no doubt about it. We won't be talking about it much in this class, probably not at all. But for those of you who aren't familiar, SQL is a method or a programming language for getting data out of large databases. So basically, you communicate with the database via SQL and tell it what data you want to extract. It is important, but for this course, we'll mostly be assuming that we're working with data sets that are in a simple file format, like maybe Excel or just in a text document. There's a question here: what are the frameworks I can use for machine learning if my computer is not of high configuration? It's really just about the size of the problem you can solve. Any laptop should be able to solve a simple linear regression problem, as long as you're not dealing with millions of data points. The examples that we use in this class will be relatively small. They might have 30 data points or 50 data points, and pretty much any modern computer should be able to handle those. It's when you get into millions or billions of data points that this really becomes challenging, and you might need some specialized hardware to do that. But again, that's not really the purpose of this class. We might want to enable you to do that down the road, but this class is more about learning the basics, which you don't need big data sets to learn the basics. In terms of learning additional coding terminology, I don't have any great resources specifically for that, but I would maybe just recommend taking an introductory programming course. So I also noticed that there's a lot of conversation about programming in the chat. That is a component of machine learning, no doubt, but it isn't the only thing. So a lot of what we're going to be focusing on is the math behind it. So those are kind of the two main pieces, both being able to understand the algorithms mathematically and being able to implement them or use a computer package that kind of enables you to run them. So I wouldn't say, that's not the only focus here. In terms of how advanced the coding will be, we're going to try to keep it as simple as possible, because again, this isn't a coding class. It's about machine learning. So we don't want that to blur the concepts we're trying to convey. And so yeah, let's keep the focus both on the math side of things and the programming side. I will add the name of the Python book in the chat.
And to answer someone's question in the chat, most of the coding is going to be optional. So we're going to have we're going to talk about coding towards the end of the class as sort of optional segment. But the coding really isn't too advanced. So I would say, just a basic understanding of a programming language will help a lot in the coding. Will we need to know how to do algebra? Yes. So yeah, so you would need to, so again, the prerequisite of this course is a beginning introductory algebra course. However, I will say that you do not need to be very experienced in algebra at all. In fact, we'll be covering many things such as summation notation and things of that nature as we go along in the course. And Jason, yeah, we will be showing coding examples, but they will be optional.
Yeah, so it will be difficult to complete this class without a background in at least basic algebra. Knowing how to solve a linear equation, you know, understanding what a system of equations is would be helpful. Understanding some basic aspects of plotting would be helpful. So, you know, we're going to start simple and build up, but we do need to start with kind of a common base of mathematical tools, and algebra is one of them. Oops, I just sent, apologize, I sent those books as a direct message, not to everyone. I just put a link to the book that I referenced in the chat. One of the questions is about what kind of homework will be assigned during this class. A lot of it's going to be more focused on the concepts rather than specific examples. Again, that's really what we're trying to highlight here. As Shreyas said, tongue twister, the programming will be optional. We're not going to force you to do it, and we don't have that as an expectation. We encourage it. We highly encourage it if you already know how, because it'll help you understand the concepts. But there will be a little bit of math in the homework, and mostly kind of trying to test your understanding of the major machine learning concepts.
I will say though, I would recommend you guys learn how to, if you don't know how to code yet, I would recommend you guys learn how to code, maybe through a course on Coursera or something similar. It's a really useful skill to have, especially in machine learning.
I'm going to post a link to one of the courses that I took. I took this course probably 7 years ago. So in my background as an applied mathematician, I originally learned MATLAB first, and then in grad school and during my PhD research, I learned C, C++, and Fortran. But then as I entered kind of the business world, none of those languages were used as prominently. So I picked up Python, and that course, which I linked to, taught by MIT, is a great introductory course. I'm sure there's free resources for learning algorithms as well. That's another thing that I would just do some Google searching on. If you can't find anything that you like, again, feel free to post it in the classroom. Pseudocode is helpful at times. I wouldn't say it's an alternative to programming languages. It's a good way to understand the algorithms, but ultimately the purpose of the coding languages is to implement the algorithm and actually make it useful. So pseudocode or flowchart is great for developing an understanding, but to actually do the work, we'll need programming languages down the road. And I see we are at an hour now, So if there are additional questions, we're happy to stick around for a few more minutes. But otherwise, we can move the remainder of the discussion to the Google Classroom. So one question here, what's next for us after this summer program? That's a great question. You know, we're happy to help you on your journey. I would recommend taking more classes. I would recommend finding an aspect of machine learning that you really enjoy and maybe digging into that a little bit further. Try a Kaggle competition. Maybe try to solve a problem that you're really interested in. Apply it to your science fair project. There's lots of different directions you can take it. And there's pretty much unlimited resources for learning it. Okay. Well, Shreyas, I think we can wrap up for the evening.
Yep.
Thank you everyone for attending. We'll be posting the homework very soon. And again, that will be due a week from today.
Yep. Thank you, Dr. Willard, for your great lecture. And thank you everyone for joining today's class. It was really nice having all of you and ask all the great questions. All right. Bye, guys.
Bye.
Bye. Thank you.